Welcome to the night club. Today we're doing polar coordinates. It's lesson 9.1 in your book. I have the examples written on here. First thing, I've passed out your graph paper, right? Everybody see it? All right. My polar coordinate grid goes by 30s. Okay? Yours does not. So to figure out what it goes by, count how many lines you have up until 90. Okay? How many lines do y'all have on your paper? 290. 6. Okay, 6. And basically you just say 90 divided by 6 and get that answer. What is 90 divided by 6? 15. So each one of your little marks is 15 degrees. Okay? You don't have to label all of them, but you do need to know so you can know what each individual angle is. Okay? So, polar coordinates are very similar to rectangular coordinates. Rectangular coordinates use the x and y. That's what you've used all your life in algebra. Okay? X comma y. All right? Polar coordinates are r theta. Okay? What do you think r represents? Radius. And theta is your angle. Everybody with me so far? So when it asks you in example 1 to graph, P is 360. And I'm going to do both of these on the same graph, okay, because I can label. So 3 at 60 degrees. I'm going to, you see all the circles? Okay. This smallest circle has a radius of what? 1. Of 1. Oops. I can't go back. Let me just draw it back. Oh, that's bad. Sorry. Okay. I'll try not to do that again. All right. So the first one has a radius of 1. The second one would have a radius of what? 2. The third one would have a radius of 3. The fourth one has a radius of 4, and so on and so forth. Okay? So I'm going to the third circle in what direction? 60 degrees. So that would be right there. That is point P. Easy enough? Label your things. You're going by 15. So every other one is 30 if you want to label every other one. Start at 0. So 15, 30, 45, 60, 75, 90, all the way around. So like I said, you don't have to label each and every one. Okay? For part B, we're doing Q. Q is negative 1.5 and 7 pi over 6. Part A was in degrees. What is 7 pi over 6 in? It's in radians. So you're probably going to have to change that to degrees in order to figure out where it is. Okay, so what is 7 pi over 6 in degrees? You just replace pi with what? 180. So what's 7 times 180 divided by 6? 210. So 210 is here on mine. Negative 1.5. Here's the difference. Negative 1.5 means you go the opposite way of 210. Okay? So, here's 210. I'm going the opposite way, negative 1.5. So, opposite of 210 is what angle? 30. 30. So, negative 1.5 would be about right there. That is Q.
Negative 1.5.
Negative 1.5 is what it says.
Wait, so how do you know that it's negative?
Because it says negative.
No, but I'm saying on the point.
On the point, because I went opposite the way 210 was.
So we go the opposite.
If it's negative, you don't go towards 210, you go away from 210. The exact opposite angle.
It's ours.
How'd you get 210 out of negative 1.5?
I didn't. I got 210 out of 7 pi over 6. I changed that radians to degrees. Okay?
Oh, so you just flip it to the other side? If it's negative?
If it says negative radius, you're going opposite 210 degrees. 1.5. Okay? Everybody good on example 1?
Hold on.
Example 2. This time both of them are negative. Okay? So what is negative 135? You can do this a couple ways. Negative angles go clockwise, right? Down. So you can figure out what is that clockwise, or you can just go negative 135 degrees this way if you can count. Okay? I like figuring out what would that be positive way. Okay, so all you gotta do is add what? Add 360 to it. What is negative 135 plus 360? 225. So 225 is halfway on mine between 210 and 240. You should actually have a line on yours. I just don't happen to have one on my grid. Is that making sense? Okay? But 225 is halfway, okay? Between 210 and 240. There's 225, which is also negative. I want y'all to understand this. It's negative 135. It just lags. Everybody understand that? Okay? And now, we're going what direction? To the opposite direction of that. So, 1, 2, about right there. Okay? That is point R.
Wait a minute. So
For you, what's the opposite of
Are we doing
225?
all these on the same graph or does it matter?
You can put them all on one. It's fine.
45.
45 degrees is where you would be.
But okay, so do you subtract? I missed you whenever you were finding where 135 was.
I just added 360.
Okay, that's what. Okay.
That's what I'm saying.
What I meant.
You don't have to do that. That's just the way I like to do it because most of the time they're in that order. You don't have like negative, like it's not going to tell you that's negative 30. It's not going to tell you that's negative 60. It's not going to tell you that's negative 90. So I always just add 360 to it and figure out what is the positive angle.
Okay.
Is that making sense? Okay. All right. Example 3. Example 3. I didn't write it up here, but in your book, they give you a point to look at, okay? And they want you to name it, but they want you to name it 4 different ways. And here's the special thing about polar coordinates. You can name the same point 100 different ways. 200, there's an infinite number of ways to name it, okay? The point we're naming here is 3 150, okay? So that's just one. I want us to do 3 more points with those same, that would be at the same spot, okay? So, I can have 3 150. I could make the R negative. If I made the R negative, made it negative 3, now what angle would it have to be going to? To go opposite 150. What would opposite 150 be? I'm sorry? 330. Those are the same 2 points, even though they're named differently. Is that making sense? Let me scroll back up so you can see. Okay? Be careful with my erasing here. Alright, that's as far as I'm going. So, 3, what was it? 3 and what?
330.
3 and 330?
Negative.
Negative 330? No, that was the original.
Negative 3 and 3.
Negative 3 and 330. Okay, so 330's here, right? Yeah, because this is, no.
The original was 3
That,
150.
my thing's labeled wrong. Look at it. It says 330 right here. That's 300. That one's 330. That's I got it off the internet, so I don't know. Oops. Okay.
Got off Facebook.
So here's 300, and it was negative 330, right?
The original was
So
3
my-
150.
Yeah, the original.
The original was 3 150.
Y'all are no help at all. All right. The original was 3 150.
I just told you.
Thank you. Okay, well they're like saying 330. All right, so
That's the second one.
3 150 is right here. Okay? So, I could name that if I'm going opposite 3, okay? I don't want to go towards what? 330. So that's another way of naming it. Okay? So that's the one that's right here. -3, 330. Everybody with me? Okay? What's another way? What if I wanted to go a negative angle? What would I go? I would still have +3, right?
But you have a negative one.
But I'm going negative an angle. Not -150. -150 would just get me to here.
510.
510 is way too much. Negative what? -210. This would be from here to here would get me to -180. And I need to go how much more? 30 more.
Oh,
Okay.
that's how it works. That's fine.
So that's 3 negative 210. Okay? And then I also can do it one more way. Here they're both positive. Here the radius is negative. This one the angle is negative. The last one I could make the radius and the angle both what?
Negative.
Both of them negative. So if for the last one, if I said -3, okay, and I would want to know what is that as a negative angle.
Oh, okay.
-30.
Okay.
How do you get that?
Cause you have to go.
Okay, all I did was make this angle negative. 330, positive 330 degrees, and negative
Oh, is the 3 always gonna be the same?
30 degrees are the same. Yes, if the radius is 3, the radius is 3. Now, it might change to positive or negative, but it's still 3.
So
Okay.
then you're gonna have two
The angle, the actual number changes.
And then you're gonna have 2 -3s and 2 positives.
Correct. Because right now we're going towards -30 degrees, which is this way, but I don't want to go towards it. I want to go away from it, which would put me right back at my original point.
That's just like another way, right?
All 4 of these are the same point. Every single one of them. And these aren't just the only 4. Okay? There's a whole, there's an infinite number. Technically, and I want you to do it this way, okay? But the kind of the easy way of doing it is just keep adding what to 150? 360. You just added 360. 3 and whatever that is. And then add 360 again. 3 and whatever. I mean, so there's an infinite number of ways to name it. These are just the 4 ways doing it where you have both of them are positive, the radius is negative, the angle's negative, and then both of them are negative. Is that making sense? But they're all naming the same point. Everybody good? All right. Last example, I believe. Nope, I'm sorry. 2 more examples. Sometimes in your polar coordinates, all right, y'all listen. Just like on your rectangular coordinates, do you always have an X and Y? You do, but really you don't. Like sometimes X is 0, and sometimes Y is what? 0, okay? Well, for polar coordinates, sometimes they don't even give you a theta, and sometimes they don't give you a radius. If they don't give you a theta, you just know the radius is what? 3. Well, what has a radius? Circles. So you just come over here and you say, all right, 1, 2, 3, and you draw you a circle.
That's good.
Oh, y'all screwed me up. It has a little hernia. Sorry. Okay. So, I'm sorry, I can't let it. I gotta try again. All right, let's try this again.
3 hours later.
You messed up.
You would think that would be easier, but it's not. All right, so that's R equals 3. Okay. What if it's just theta? And by the way, 3 pi over 4. What is that in degrees? 3 times 180 divided by 4. 135? Sure? Carly is exactly right. That is just a straight line at 135 degrees. Okay? So 135 would be right here. And it does go all the way through it. Okay? So this is part B. Logan, shh. This is part A. I just wanted to say your name. Logan really wasn't talking. It was Rassie is who was talking for you people on the internet. All right. Everybody good? All right. Example 5. Just like we find with regular Points, we find the distance between them. We also find the distance between points in polar coordinates, okay?
Do we have to remember that?
You do not have to, well, you have to remember it, but I'm going to give you a way to remember it. Okay? So do you have your formula sheet?
The one for like the last
The ultimate
Yeah.
formula sheet, yes. That's all, let's just start calling it that. The UFS,
Yeah, yeah.
the ultimate formula sheet.
Hey, we'll
Okay.
end this video too, so
We'll see. All right. Now, does anybody recognize this to something that we've done already in the class? It kind of looks like something. What does it kind of look like?
What's the last question? Isn't it?
The
Hang on a second.
quadrant.
No. I mean, it's got a little bit of the quadratic equation in it, yeah, but
Yeah.
Lost sign.
law of cosines.
Look at that. Yeah, you're right. That's awesome.
Yeah, I was thinking that.
All right, your law of cosines. And then remember, there's three of them. I'm just going to put one up here. It's the one that said a squared equaled b squared plus c squared minus 2bc cosine of a. Y'all remember that? Okay. And then to find a, we just did what? You took the square root of everything. This is the same thing as that. Okay? Now, there's a couple of differences, obviously. Your B and C are just your radiuses. Okay? Radii, I should say. That's the proper way of saying it. And your angle. Well, we have two angles. The way you get just one angle is you take the second angle and minus the first angle. That's your A. Okay? So, I have a basic problem here. Find the distance between L1 is 450 and 30 degrees, and L2 is 600 and negative 50 degrees. All you have to do is plug it into this. Now, you asked, do you have to remember that? Not really, because what is on your formula sheet? The law of cosines. So you just have to be able to, in your brain, convert law of cosines to this.
Yeah, that's fun.
Okay? And if it's on there, you can do it. All right.
I know that.
Sure.
Are we allowed to write on our phone?
No. All right. So we're going to find the distance. What is my first radius? 450. So we're going to say 450 squared plus, what's my second radius? 600 squared minus 2 times 450 times 600 times the cosine. What is my second angle? Negative 50 degrees minus 30 degrees. And we put all of that in our calculator. Now, before you put it in your calculator, everybody hit mode. And what does it need to be in? Degrees, because we're using degrees. Now, they will give you problems that they give you radians. If they do, you need to make sure it's in what? Radians, or you can convert it to degrees and just leave your calculator alone. Everybody with me? Okay? So, this, when you put it in your calculator, and you round it, because it is going to be a big long decimal, it will be, what'd you say you got? 684.6. And that was in, well, I didn't tell you this, but that was in feet in the word problem. But we don't need that because I didn't write the word problem. All right?
Does it always lag like that?
It does always lag. Any questions on how to do those?
Should we complain again?
No, I'm not going to complain. Everybody good? Next week.
That means just put them in shot.
Everybody good? All right. We'll stop this one. Hey, that was less than 20 minutes. That
Hey, you
ain't
didn't
bad.
say it, say it, say it.
What?
You didn't do the music.
Oh, okay. All right. I gotta say, okay, this lesson was straight bussin', respectively. Respectfully. See, I said it wrong. Now people on the internet gonna think I'm an idiot.
You say it right next to
Sheesh! Alright. Can't get out of it, get into it. Stay above the line. We'll see you next time.